Alright, so let's finish this off with using the quadratic formula. And of course, Edmentum decided to make it a little complicated with us by putting a root here. So we have a root inside a root. Let's get this going. The interesting part is it doesn't even look like we have, well, we will have it. We'll have, it looks like we're not going to have imaginary numbers, but you'll see in a second that's going to cause us to have a negative discriminant. So using the quadratic formula, we're going to do negative b, which is 14 plus or minus the square root of 14 quantity squared, because that's supposed to be our b squared. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's the song of Pop Goes the Weasel. The only thing I ever remember about the rhyme is all over 2a, but it's negative b plus or minus square root of b squared minus 4ac all over 2a. Again, I heard that helped people, but it never helped any of the people I talked to. We were just always like, oh, it's something, something all over 2a. So we do that, and then we do minus 4. Our a again is 1, and our c is 4. So what ends up happening here is we get this negative square root of 14 plus or minus the square root of this squared and this square root cancel out. I should have probably done that in a different color, so let me do that in red. So that square root and the square cancel out. So that means we just get 14 minus 4 times 1, which is 4, times 4, which is 16 in that square root. So we'll see that we're going to get a negative discriminant here all over 2. So we end up getting this negative square root of 14 plus or minus the square root of negative 2 all over 2. So, and let me draw my arrows. I know I'm like going all over the map here. So this ends up being negative square root of 14 plus or minus the I, because we're getting rid of that negative from inside the square root, 2 all over 2. So let's see what it has here. Use the dual plus or minus symbol. So they do want us to write it exactly like this because they're saying right here, use the plus or minus symbol for dual roots because we're going to have 2 roots here. All right, so let's see how picky Edmentum's going to be with me right now. Let me actually use the eraser because I don't want to erase too much. I wrote the answer in a bad spot. Let me see how much I can write in here. So I'm going to put, I'm hoping they don't want me to distribute out the negative, but knowing Edmentum, they might make me. So here we're going to do negative. I'm going to do, where's the square root? Square root of 14 over 2. And the 2 does not divide the 14. Remember, only things inside a root can divide each other. The 14 is in a root, but this 2 is not in a root, so it does not divide the 14. We're going to use a plus or minus here, so there's this plus or minus symbol, and then we're going to do another fraction. So remember, we want the I on the side, so we're going to do our symbol here, and this is going to be square root of 2 over 2, and again, the 2 does not divide the 2 because this 2 is in a square root and this 2 is not, so they cannot be divided by each other. So now I can delete this because I wrote everything down. The only thing I'm missing is my I, which I said we're going to do here on the side. So let's see how picky Edmentum is with my answer. Yep, I figured that was going to happen. So check the value of the discriminant again. Make sure you multiplied, added, and included the correct symbols. I don't know what it's going to want from me, so I'm just going to do it again, and we're going to see what the answer is, because Edmentum, yeah, that is done exactly the way it's written here, but Edmentum is saying that it's the wrong answer. So I'm sorry, guys. This is one of the reasons why I prefer hand-tested things. I don't know if I'm like typing something in wrong somewhere, but that should be the correct answer. Edmentum is just being super picky right now, because that is exactly how I typed it in. Let's just move on. All right, so this one, oh boy. One thing you'll notice is that this is an equation. So one thing I recommend is, if you ever have a fraction and you're like, I don't like fractions, let's get rid of them. But this is going to take us by knowing the lowest common multiple. So remember, multiples are what something turns into. So for example, multiples of 2, well, let's talk about multiples of 2. Lowest common multiple slash lowest common denominator. So it's basically the lowest common multiple of the denominator. It's just, I don't know why in the math community we use these terms interchangeably. Lowest common denominator, that doesn't even make sense technically. It's technically supposed to be lowest common multiple of the denominator, but somewhere along the lines we just call it lowest common denominator just to make it easier. But anyways, multiples of 2 are 2 times 1 is 2, 2 times 2 is 4. We're basically just adding these up. Multiples of 3 are 3 and 6. And right off the bat, it's like, oh, cool. The lowest common multiple is 6. That's the lowest number these two have in common. So we're going to multiply everything by 6. And what this does is it gets rid of our denominators without really changing the equation, because since we're multiplying it, since this side is 0, 0 times 0 is 0. So if we do 6, this 6 reduces this 2, and we just get 3x squared. And this 3 reduces that 6, and we get plus 2x. And this 3 reduces that 6, and we get plus 2, and it's going to be equal to 0. All right, and from here, we could use a quadratic formula, but why? I mean, actually, let's do it, because I have a feeling, since this is a complex number one, we're probably gonna have to do it, because I just realized this won't work, because we'll end up having to get 3 times 2 would have to go on the top, and then 2 here, so we'd have to have a box method for this and this. There's nothing that added together will multiply into 6, or 2, sorry. 2 things that add up to 6 will never multiply into 2. So that's why we're using the quadratic formula. So I answered my own question there. So that means we're going to be dealing with imaginary roots, and I should have expected that going into a complex thing. So what we're going to do here is we're going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so what we get here is negative 2 plus or minus the square root of, what is this? 4 minus 4 times 3 is 12, times 2 is 24, all over 6. So we end up getting negative 2 plus or minus the square root of 20, negative 20, all over 6. And remember that even though you can't divide the 6. What can happen, though, is you can still take the square root of 20. So when we do a factor tree for 20, we have 4 and we have 5. All right, so the 4 turns into 2 and 2. So that ends up being 2 goes on the outside and this 5 goes on the inside. But since we're dealing with a negative 20, we're going to put a little I there too. So we get negative 2 plus or minus 2I square root of 5 over 6. And I'm going to erase all the previous work so I have room to write it. This time I made sure to kind of write the answer in a spot where I can look at it. That way, when I get upset at Edmentum, I have proof that I wrote it down correctly. So that being said, let's split this up into its two parts. So for splitting this up into its two parts, it's going to be negative 2 over 6 plus or minus 2I square root of 5 over 6. And what you'll notice here is now we can divide something out because this 2 is on the outside. It does have an I there, but that doesn't change factoring. It's kind of like when you have 2x over 6. So this changes into negative 1/3 plus or minus 1/3 square root of 5I. So what I'm going to do here is this 1 kind of doesn't matter too much right here. So let me erase this part because unfortunately I didn't have room there. So what ends up happening here is, first of all, Edmentum's going to hate me for how I write it. But this is going to end up being negative, get my fraction here. You know what, is there a negative button? Maybe that's why Edmentum's been yelling at me. No, I just see a minus button. So this should be 1/3. And then we're going to do the plus or minus sign. And that's going to be a fraction here. We're going to do square root of 5. This is going to be a 3. And we're going to put that little I on the side. Let me see if there's an I that they want me to use. I don't see one. So let's try this, see what Edmentum says. And of course it says I'm wrong. Let's submit it again. And we can see what I'm writing here. Let's do an answer. 2/3. Let's see how they somehow got rid of that 2/3. They decided to make it complicated. If I multiplied that out, oh, I see what I did wrong here. I'm so sorry, guys. What I did wrong was I forgot that the 3 reduced the 6 to a 2, but that would mean that this is going to end up being 4. So it would end up being 3x squared 4x plus 2 times 4 would be 8. So again, that was my bad. So Edmentum actually wasn't at fault on this one. This was me forgetting to distribute my 2 after the 3 reduced it. So what basically happened is I'm going to do 6 times 1/2. Well, that half of 6 is 3. And then I'm going to do 6 times 2/3. Well, this turns into a 2, so that makes it a 4. And then I'm going to do 6 times 4 over 3. Well, this turns into a 2. So then it's going to be an 8. So then I'm going to do the quadratic formula of that. And if I do that, what will end up happening is they skipped a lot of steps. I really hate how Edmentum skips these steps because I can see it, but if you need to see all the steps, you're going to miss out on it. So they did it with the fractions, and it looks terrible with the fractions. It really should be -4 plus or minus the square root of b squared. 4 squared minus 4a is 3. Uh, c is 8 all over 2a, which is a 6. And here you can kind of start see, 3, which will turn into a 6 later. So I was right about this one, but that's just because it was 1/2 in the front. So what will end up happening is we get -4 over 6 plus or minus whatever this is. So 4 times 4 is 16 minus 12 times 8. 12 times 8 is 6. Carry the 1. 96. So that ends up being the square root of 80 over 6. If we break down 80, we get 4 and 20, and this ends up being 4 and 5, and we don't even have to break down the 4's because we have a pair of 4's there. Perfect. So this ends up being -4 over 6, and by the way, this is a negative because all of this was -90. Um, and that's the reason why I got that is -16 minus 96. That'll equal 80. So that's where I got that -80 from. So I end up getting plus or minus 4i square root of 5. So everything was kind of doubled because I totally forgot about those numerators. I kind of just focused on canceling out the denominators, and I completely forgot about the numerators. So this will give us our -2/3, 2/3 of I square root of 5, I there, and the plus or minus there. So that one was on me. It was not on Edmentum, and I had the proof there to show it. So I just don't like how they use fractions. So using that lowest common denominator part is still useful. Let's move on to page 50. So a summary. This is just talking about how in these centuries, the 16th through the 18th centuries, we devised these numbers just as a way to kind of derive this. Rene Descartes, you'll probably know him from philosophy. He's the guy that said, I think, therefore I am, meaning that because I'm a thinking individual, that means I exist. He was a big mathematician. He discovered a way to kind of do complex numbers and real numbers together. And later, mathematicians figured out how to do addition, subtraction with complex numbers. So it took us a while to learn how to do all the math that we just showed you. And we can write here about all the powers and the cycles. I like thinking of it as a circle, but I kind of like how they expressed it as a square, where this is I squared, this is I cubed, and this is I to the fourth, and I'll keep going around and around this square, which is weird to say around the square. All right, and as always, just look over your summary video to help you out, and that's the next module. So let me go back over here. So as I mentioned before, we're going to exclude polar coordinates, and we're going to exclude complex numbers with the Morse theorem. It's just a little too complex. Polar coordinates is a different way to kind of write it out. You'll probably see it in the activity, but polar coordinates is just a different way to do it with vectors. We kind of did polar coordinates when we did vectors, so it's kind of pointless to do it again. Complex numbers with this formula, it just gets too out there and it's not on the mastery test. So our next video will be module, if this is 4, 5, 6, it's gonna 5, 6 is gonna be on module 7, which is complex numbers in a plane. So we'll get to see how to graph that and talk about that. All right, so see you guys on the next video.